This is the world's first all-in-one kitchen appliance that combines the functions of a blender, food processor, and a classic bowl mixer. With this device, you can blend, chop, and mix without storing or moving the appliance. It allows you to save space in tight kitchens, and it allows you to eliminate single-purpose appliances, saving money. In this video, we're going to talk about the design and design processes of making something like this work. So I cook every day, and I really love to cook. And by proxy, I have a lot of kitchen tools and gadgets and different supplies for my kitchen. But one thing that's always frustrated me between all the places I've lived since college is the amount of storage space I have in my kitchen. And more specifically, how much space all those different kitchen tools and gadgets actually take up. Let's take these three for example. Here you have a food processor, a blender, and a stand mixer. Why do these need to take up so much space? What is special or different about each of them that requires so much room dedicated to it, especially when you only use it for short bursts every couple of days or only for one thing? Like this whole blender that takes up 2 cubic feet of my limited cabinet space can only blend things? Why is there no way to get all of these functions in your kitchen without taking up all this valuable real estate? And because they only do one thing each, I have to spend my money on 3 different products? So I thought I would try and solve this problem. I have a 3D printer and some CAD knowledge and plenty of experience breaking things. Maybe I can make something that works better. So the first step of any engineering task is understanding the problem you're trying to solve. Kitchen countertop appliances just take up too much space. And because kitchen countertop appliances usually only perform one main function, you end up having to buy multiple appliances, which can start to add up very quickly. The easiest way to solve them is to ignore the limited functionality and just store stuff outside of the kitchen, especially things that you don't use frequently. But I just said I have very limited kitchen space. Do I really want to keep my stand mixer in my closet next to my clothes? Or maybe keep my blender on my nightstand? I don't think either of those are viable long-term solutions. The next way, and the way that I decided to try and solve this problem, was to combine these single-purpose devices into one multi-purpose device that covers the 3 primary functions of blending, food processing, and bowl mixing. So where should we start? We'll start with the thing that drives it all, a motor. The best way to figure out how to combine these appliances and their functions was to take a peek under the hood of how they already work. When I started taking stuff apart, I noticed something similar in each one. Effectively, all of these tools are just a universal type motor attached, or in some cases not attached, to some sort of gearing, or just a work implement. A universal type motor runs on your mains electric power, and generally can only run at very high RPM or it will stall or stop spinning. How manufacturers get around this is by using different size motors for different speed regimes. A blender and a stand mixer do not need to run at the same speed or have any of the same level of torque, so they would not have the same size motor in them. For example, this is a motor from a high-powered blender, and this is a motor for a food processor. The larger one can exert more force and therefore spin faster, so it's better suited for blending and super high-speed applications. This is a vast oversimplification of how universal motors work, but the basic understanding of how they are sized for different applications is very important here. So far, I've taken apart around 4 blenders, a food processor, and I've popped the hood and looked inside a very expensive stand mixer. And in all of them, the motors are sized differently for their different speed applications. When we talk about motor sizing and why it's important, a blender needs to spin at 10,000 RPM or faster to properly blend and liquefy ingredients. But a food processor only needs around 10% of that speed, or 1,000 RPM. And if you tried to run a stand mixer at any rate above 100 RPM, you would have quite the mess on your hands. Because this problem is primarily solved in the industry by motor sizing for the different speeds and different appliances, how would we go about solving it in a combined application where we'll only have one motor? The answer is gears. The best bet is speed reduction through gears. In other words, using a motor that can hit the top line very high speeds and reducing its power so that it can also hit the lower end speeds. The best solution for this type of problem is a planetary gear reduction. Planetary gears are used everywhere, from your car transmission to wind turbines. And oh look, they are already used in this cheap Amazon food processor. A planetary gear system works by taking a central input and spinning planets locked within a ring gear. Depending on which position is held, a planetary gearbox can vastly reduce the speed of an input. For my application, what I would actually need is a multi-stage planetary gearbox, one that can take a central input and output 3 distinct speed regimes for the 3 independent functions of blending, food processing, and mixing. We can accomplish this by chaining planetary gearboxes together, or better known as a compound planetary gearbox. These are also quite common, but a little more rare. This, with some clever design work, would allow a single input to output 3 concentric speeds. The central speed would be the highest speed, or the same speed that the motor is spinning. The planet speed would be used as the medium speed output, and the outer ring, which would be used as the lowest speed output. After designing the gearbox, you get something like this. When you spin the central shaft, all concentric rings spin. Tapping into each of those rings will get you different levels of speed, and you get the added benefit of multiplying torque, which is especially important for lower speed applications like mixing doughs. What we have done with the gearbox is increase the total operating speed limits of this motor. The gearbox allows us to hit much lower speeds, but because of the space constraints and design limitations, when you run the motor at its very top speed, or 10,000 plus RPM, or the design speed, the outer or low speed ring is still far too fast because you're not able to get a significant enough gear reduction to really run at the low speeds. So now we have to introduce our next variable, which is universal motor speed control electronics. So I started at the top of this video by saying that manufacturers control speed by motor sizing. Well, that's not necessarily always true. You can control the speed of rotation of a universal motor, but only within a 20 to 30% band of the top line speed, which would not be enough speed control to hit all the target zones for a device that needs to spin as fast as 10,000 RPM and as low as 20 RPM for the different applications. This was the hardest part to solve. As universal motors are all sized differently, speed control with any sort of fine detail is very difficult, and not many off-the-shelf parts or solutions exist. For the longest time, I was using the speed control from a blender that I had disassembled, but it wasn't really designed to get to the lower end speeds I wanted to get to. Ultimately, I found a DIY solder-it-yourself kit from Velamin that has been discontinued, but works really well for this application. It works by lowering the voltage and signal to the motor and chopping that signal up into really small bits in the waveform. I'm not an electrical engineer, but this works, and that's my basic understanding of it. So with this universal motor speed control coupled with the gearbox, I can now run this at very low speeds all the way up to the highest speeds. So I can hit all the target zones for blending, food processing, and stand mixing. But we forgot one thing. How in the world are these actually going to do the tasks that we set out to do? Do the actual blending, do the actual food processing, do the actual bowl mixing? Well, we got to design some attachments. So for a first go of it, I took some existing parts like a blender jar, a food processor jar, and a cheap stainless steel bowl that I got off Amazon. I designed and 3D printed some adapters and made them line up with their correct speed range on the gearbox, slapped them on, and called it a done deal. This worked well, but it wasn't really a viable long-term solution. There was no safety mechanisms, and the parts could jump off of the gearbox with a bump. But with this prototype, I had finally proven out my hypothesis that this could work. You can build a device that combines the functions of a blender, a food processor, and a stand mixer. The next step for us was to make it look nice and bring the overall design vision together. So I started designing a blender and a food processor that could be compact but still offer all of the capacity and features top-of-the-line appliances use. I also designed a locking mechanism that will ensure that even under load, nothing will pop off and go crazy in your kitchen. With some more 3D printing and then some more 3D printing and some quick 3D print orders to get these clear parts, I now had a pretty good looking functional model of what I set out to do. This is the final product. This is the Universal Kitchen Station, or what I'm now calling the Maestro. It's a device that combines the functions of a blender, a food processor, and a stand mixer. It's compact, it's efficient, and if I don't say so myself, it looks great. The blender and food processor fit neatly under kitchen cabinets and in your cabinets. The base unit can live on your countertop without taking up so much space. It has a top speed of 10,000 RPM and can go as low as 10 RPM for very slow applications. One thing that I kept in mind while designing this was ease of repair. This device is easy to assemble and easy to replace components that break, so the overall lifetime of the device should be a lot longer if I can supply spare parts. The last great benefit of this device is that it's expandable in the future. Because we increase the operating envelope of speed and power with the gearbox and the universal motor speed control, we can now build other attachments that serve all sorts of purposes, such as a meat grinding attachment or a juicing attachment. Anything in your kitchen that uses rotary power could effectively be powered by this, eliminating the need for more single-purpose appliances. So I'm going to be doing a series of videos on the various design challenges I faced in prototyping and around the attachment designs in separate videos. This is far from a finished product, as the final PCBs and control boards are being built that will move the controls back inside the unit, and the blender is being optimized for way better performance. But we expect to finalize those details relatively soon, and we'll probably be launching in a couple of months. In the meantime, please support by going to our website at mykitchenlab.com and sign up for our emails if you'd like updates. You can follow KitchenLab on Instagram, TikTok, or Facebook to get updates that way as well. I really appreciate you watching. If you've got any questions, leave them in the comments and I'll make sure to answer them. Thanks.